Hello Algebra 1 students. I've been looking forward to this video for a long time. I think it's due. I've told you many times that when you solve a quadratic equation by completing the square, you're really doing the same thing as when you use the quadratic formula, and that the quadratic formula is completing the square with all the work done for you. This video will show why that's true. This is known as the derivation of the quadratic formula. Where does it come from? Step by step, using legitimate algebraic steps, to go from ax squared plus bx plus c equals 0. Of course, that's the quadratic equation that is associated with the standard form quadratic function. Now, these little whiteboards I've been using are not quite big enough for me to show the entire derivation. But of course, where we're going to end up is well, you get the point. Where we're going to end up when we have ax squared plus bx plus c equaling 0 is that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's see how we get there. Just as with any time we're completing the square, there are two preliminary steps. The first is to get that c on the other side. And when a term changes sides, it changes signs. There's a little mantra from algebra that I'm not that fond of. I don't use it a lot, I don't think. But when a term changes sides of an equation, it changes signs. Subtract c from each side and you'd be here. Well, there's a second preliminary step. It would be very difficult to complete the square with that a there. So let's divide through on both sides by a so that we have an equivalent equation where a is 1, where we have just the x squared. And that's going to give us this. If we divide through on each side by a. Now on the right side, negative c divided by a. There it is, negative c over a. On the left side, dividing this term, we have to divide each of these terms by a. Dividing this term by a gives us x squared, which is why we did it. Dividing bx by a, there's actually a couple little steps there. You start with bx over a. And this is probably, you've probably internalized this by now. Just do it automatically. But in case people are wondering, there's actually this little progression. You have bx divided by a. You can think of that as b over a times x over 1. If you were to multiply these two fractions together, you'd have bx over a. Well, x over 1 is x, so b over a times x. That sort of thing will become automatic. You're not going to have to think through all of that. I just wanted to make sure. So now we're ready to complete the square. And what is that little mechanical device that always works? Take half of this and square it and add that to each side. That's how we complete the square. What is half of b over a? 1/2 times b over a is b over 2a. We want to square that. Write it down if you think you'd have trouble with that. What is b over 2a in parentheses squared? b over 2a times b over 2a. It's b squared over 4a squared, right? Make sure you agree with that. So we're going to add that to each side. X squared plus b over ax plus b squared over 4a squared. And then, so I added b squared over 4a squared. That's b over 2a squared. I added it to the left side. I'm going to add it to the right side by putting it first. Why am I putting it first? Well, because I kind of know where we're headed, and it's just going to look more normal if I put it on the left side. So b squared over 4a squared, and then minus the c over a. Right? And notice what I've done here. I had negative c over a, but that's equivalent to minus c over a. Okay? So we have just completed the square, and we have kept both sides of the equation equivalent by doing the same thing to each side. I'm going to do one last thing on this board and then move to the second board, because the thing I'm going to do here on the left side should be easy and obvious. How do you factor x squared plus b over ax plus b squared over 4a squared? Well, we just created that perfect square trinomial. We just completed the square. So we should be able to factor this thing, and it factors as x plus b over 2a squared. The same b over 2a we got when we took half of b over a. Well, this thing factors as x plus b over 2a squared. And that's going to be equal to this. I'm going to pause and go on to the next board. So in our derivation so far, what we have is x plus b over 2a. I wrote that kind of funny. X plus b over 2a all squared equaling this right side that we had before. And before we continue with the derivation, I just want to make sure that you're good with this being equal to what was above it. X plus b over 2a, when you square that, of course it's x plus b over 2a times x plus b over 2a. And you recall weeks ago in a previous chapter, we learned how to multiply two binomials, the so-called FOIL method. That should be something that's easy and automatic at this point. We're going to do x times x to get x squared. This x times this b over 2a is going to give us plus b over 2ax. Now we're going to shift to this b over 2a and multiply it by x, but of course we're going to get another b over 2a times x, plus b over 2a times x. And then we're going to multiply b over 2a by itself, by b over 2a, and get b squared over 4a squared. Now this doesn't look quite like the perfect square trinomial just yet, because we have to add the two middle terms. How do you add b over 2ax plus b over 2ax? Right? The denominators are the same, so it's going to be b plus b over 2a times x. 2b over 2a. b plus b is 2b, so it's 2b over 2a times x. The 2's can cancel, leaving us with b over a times x. And if you look back in the derivation, this is the perfect square trinomial that we created right there, and we factored it as x plus b over 2a squared. So pause the video if necessary. Make sure you're good with all the steps so far. So here's where we were. I erased the quadratic formula down here because we're probably going to have to go on to a third board just to keep things nice and neat. All right. We have a number squared equaling a number. I've shown you this before as x squared equals a. Whenever x squared equals a, x equals plus or minus the square root of a. Well, what's the x here? Well, the x is actually x plus b over 2a. That's the number that's being squared. And what's the a? It's this, right? This needs to be an automatic reflex so that we get x plus b over 2a equals plus or minus the square root of b squared minus 4a squared minus c over a. Subtract b over 2a from each side and get x equals negative b over 2a plus or minus the square root of b squared over 4a squared minus c over a. And ladies and gentlemen, I would like to make this point. That's the quadratic formula, or that could have been. It is a quadratic formula that works because this is equivalent to the quadratic formula that we all know and love. In order to get to the quadratic formula that we know, we have to be able to simplify this root. And the first thing we're going to do is notice that inside the square root, we've got two fractions being subtracted. They don't have a common denominator. So let's give them a common denominator and subtract. I'm going to do just that part of it right here. I'm taking what we now have underneath the square root sign, and I'm going to do this. I'll put the square root sign above it. So I've taken this square root, written it down here. But instead of minus c over a, I've written minus 4ac over 4a squared. What have I done? I've identified 4a squared as the common denominator. And I've converted the minus c over a into an equivalent fraction that has 4a squared in the denominator by multiplying top and bottom here by 4a. 4a times c, 4ac. 4a times a is 4a squared. Now, of course, we can add those two fractions and get b squared minus 4ac all over 4a squared. Right? The approach here is no different than in 5th grade when you're subtracting two fractions. It'd be like this denominator is, let's say, 24, and this one was 3. We multiply the top and bottom by 8 to get the common denominator of 24. It's the same thing. All right? Multiply the top and bottom here by 4a to be able to then subtract the fractions. And one thing I want to say here, as you go forward with the derivation of the quadratic formula, you start to see elements of the final quadratic formula. Of course, the b squared minus 4ac. We recognize that from the final version of the quadratic formula. I'm going to pause here and go on to another board. I've copied up at the top here what we ended up with after adding the two fractions inside the square root sign. We have x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 4a squared. At this point, we need to simplify that square root by a technique that I've introduced you to. There are two identities, two laws in math that work with some restrictions. This y and this y cannot be 0, but this one can be stated as the square root of a product is the same as the product of the square roots. And there's a similar one, very analogous, that the square root of a quotient is the same as the quotient of the square roots. You can break the square root of x over y apart into the square root of x over the square root of y. And that's what we're going to do up here. We're going to rewrite what's in the square root sign. We're going to rewrite it this way. The square root of this quotient is equivalent to the quotient of the two square roots. The square root of b squared minus 4ac over the square root of 4a squared. Okay? And you should see now that we're almost there. You may not need me to do the final step. Because what is the square root of 4a squared? It's 2a. It's the same as that denominator. So negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. I'm not going to write the final step because the final step is to just add these two fractions. Well, add and subtract. We're going to keep that plus or minus, right? If you add these two fractions, they now have the same denominator of 2a. What are you going to get? Negative b plus or minus the square root of b squared minus 4ac all over 2a. You would have the final form that everyone works with and remembers of the quadratic formula. That's it. It's a lot of writing, but each step is logical. Each step is small to go from one to the other, and I hope you've enjoyed this. It is in your textbook. It might be slightly different, the derivation that's in your textbook. I might have done 2 steps in reverse order of what your textbook authors did, but they'll be equivalent, mine and theirs. And I'd recommend that you not commit it to memory, but be able to reproduce it. Be able to reproduce it step by step. Somebody that's serious about Algebra 1 probably should consider it. I'm not going to hold you responsible for it. I don't know if your Algebra 2 teacher will hold you responsible for deriving the quadratic formula, but it's like, why climb Mount Everest? Because it's there, and this is a lot less dangerous. So enjoy the derivation of the quadratic formula. Bye-bye for now.